good sermon has really 3 points, so this is a very short sermon with 3 points. I just want to frame the discussion here in terms of the characteristics of cloud computing, the business values, and the ideas or examples of data historians as a cloud application. In terms of the characteristics of cloud computing, that's really my first point is that we are at a kind of a disruption. This represents a really big disruption, which is a happy thing in some ways. It disruption is not always happy for people who are experiencing it. But surprisingly, we've had a lot of references to the GE Industrial Internet Report. There were economists who prepared that report. Believe it or not, there's a substantial fraction of economists who think that we're kind of at the end of history in terms of development. We can't really continue to increase productivity anymore. And these kind of disruptions represented by cloud and so forth are good indications to the engineers, the technologists, the scientists, and the kind of more optimistic folks that that's not true. And we're looking at it in ARC as one of the disruptions that's going to drive what we call our information-driven manufacturing vision. So cloud, big data and analytics, Internet of Things, all of these new technologies represent disruptions. The complexity of the cloud computing model is that it has very different service models and it has very different deployment models, which is in our manufacturing field, I think is a very good thing in that many of the kinds of applications and services that a manufacturing facility would want are not in the mainstream necessarily of IT. There are a number of useful features associated with the cloud in terms of improved economic performance and also flexibility. And I'll talk about those a little bit, but the key ones, which are defined by NIST, and NIST, by the way, has a very nice definition of cloud computing if you just want to Google NIST cloud computing definition. On-demand self-service, which means really scalability, access to mobile devices, which is a big limitation in many manufacturing applications, and measured service. And I'm always astounded at how long it takes, and I shouldn't say this because it's the same way in our company, how long it takes to deploy a server and an application. And these kind of measured service models where you can quickly deploy is a huge value proposition for new applications. One of the things that the different service models mean is that the products that are delivered through the cloud are very different depending on which layer of the stack you're interfacing with. And those different service models basically mean which layer of the stack are you interfacing with, the top one being the Salesforce.com as the model. Excuse me. That's why it's on silent, but not silent enough. That's my daughter. And in the middle layer, you'll be interfacing more to pure technology, software technology, and at the lower layer, really virtualization or virtualized services and storage and so forth. So depending on what layer you're interfacing with, there are very different product sets interfacing in those layers. And then sure enough, depending on what layer you're interfacing, there's very different customer sets. So we're all most of us, end users, are the types who would be interfacing to a Salesforce.com. But it's just as important, I think, that application developers can interface. And that's one of the disruptions this represents, is that there's a whole new software development, deployment, and service model for software developers. So this really represents a disruption to the software industry as well, which, as I said, is not maybe nice if you're experiencing it, but is something that drives progress. And then at the lower level, it's really your IT folks, and in our company, and I'm sure many of your companies, it's the IT folks who are really interfacing at the lowest levels of the cloud stack. And there's a nice Microsoftian picture of the cloud stack. Another point that I would raise about that is that in all cases, and when we're talking about a cloud infrastructure, we're interfacing with a virtualized infrastructure, which is what gives it a lot of its power and it really distinguishes it quite a bit from what before the cloud era was just plain IT outsourcing. So that's the first point, kind of the characteristics of cloud computing: networked resources that are now networked remotely over the internet with different strokes for different folks in terms of the service models and the deployment models. Now, what about the business value? That's point 2 out of 3. One of the things that is astounding, I think, is how big the cloud business is. And why is it so big? It's so big because it underlies all of the internet services that we use every day as consumers. ARC did not come up with this estimate, but there's a reasonably accurate estimate of the data center spend annually is something like $80 billion worldwide. When I first heard that, I thought the decimal point was off by 1. But no, that's a reasonably accurate estimate, although we don't research that market at ARC. But it's a huge spend already, and what that does is, because it is huge, because it has the support of major IT, internet, and software companies, there's very rapid development in the space. So it's getting mature very, very fast. So we see things developing in all kinds of areas, from the DC data center with new servers, entirely new designs for servers that are maybe based on different processors, all kinds of changes that are disrupting that level, as well as disruptions in other places. So it's really a wholesale disruption. Business value propositions generally are around reduced capex and speed. And what the buzzword that they use is elasticity, which means scale up and scale down, and the ability to serve mobile clients better, which has been traditionally, depending on which vertical industry you look in manufacturing, has been I would say, a chronic pain point for many industries. Point about that reduced capex and rapid deployment, just think in terms of your company, how long it takes from the time someone decides to deploy an in-house server until it's purchased, deployed, commissioned, and in service. And in many cases, I would say not backward companies, but pretty good companies, that can be 6 months. I hope yours is less, but I wouldn't be surprised if that's a reasonable estimate of how long it takes. So the rapid deployment aspect is very, very important and can be very valuable just by itself. Okay, well, that's cool IT stuff, but how would it impact our plans? Well, these are the kind of business values that we see driving cloud, and basically what they come down to is the kind of values that were delivered through outsourcing, where somebody else is taking care of some very difficult or complex services, and at the same time converting capital expenditure and capital project management to more of an operating expense or OpEx proposition, which is always easier for a customer, a measured service and a managed service business model. Of course, there are many business models, but that is the gist, or that is probably the key point from the business standpoint. This is a little slide just showing the kind of business model of a application deployment, and it's kind of funny, I think, because it shows the infrastructure going from 0 to some value at time 0, and as I mentioned before, that's usually 6 months into a project at least. So it is a long kind of service cycle. Oops, now let's go to the third point. Okay, third point out of 3 is looking at data historians and really production management software as a cloud application. And these applications are very near and dear to the hearts of many manufacturers, and some of the folks in the room create and deliver these applications for manufacturers. They're very key in terms of manufacturers being able to derive improved performance and value out of their extremely capital-intensive plants. So, and in the case of history, if we look through history, these were the applications that emerged and jumped off of, if you will, the DCS platforms of the early DCS era onto the workstations and servers and whatever was around at the time in the 1980s. So these kinds of applications, which would be the plant or enterprise historian, production planning and scheduling, MES applications, were very attracted to the IT environment of the time because it had more resources, you could expand and upgrade it, and it was less tightly coupled to the actual safety and security that were provided by the regulatory controls, whether they were whatever form they took. So our kind of question at ARC is, how long do we expect, or what kind of evolution do we expect as these applications move from a conventional owned IT model to a cloud model? And we have noticed an awful lot of companies talking on the supply side about doing that with particular products, generally being kind of cautious, I would say, in terms of what they say publicly, but obviously a great number of suppliers have given it some thought and are putting this kind of technology very front and center in terms of how they do product planning for the future. And if you want to read more, we have a strategy report at ARC on this topic, and we'll certainly be publishing more in the future. So I would encourage you to read that report and ask ARC. We'd be happy to talk about it with you anytime. So that's the end of my brief sermon.